We're going to continue talking about conditional probabilities, focusing mostly on independent and dependent events, but also talking about the probabilities of intersections. The probabilities of intersections can be found using tree diagrams, tables, and lists, but we can also use the multiplication rule, which says the probability of A and B is equal to the probability of A times the probability of B. So for the first one, given 2 dice, what's the probability of getting a sum of 5? This one's easier with a diagram. There are 36 possible outcomes and 4 favorable outcomes, so that gives us a probability of 1/9.
Dr. Wolf, you have a call.
For the next one, what is the probability of rolling a 2 on the first and a 3 on the second? Well, here's our first die, and here's our second die. We have 6 possible outcomes in the first one, but we only want 1 of them. 6 possible outcomes in the second one, and we only want 1 of them. We multiply that together, and we get 1 out of 36, which I can also see from the table, but we could do it with the multiplication rule. Now it's time to talk about independent and dependent events. Independent events do not affect the outcomes of each other. Dependent events do. So obviously you can see some relationship here with conditional probabilities. So let's look at some examples and see if we have an independent or a dependent set of events. Elise picks a card from a standard deck at random, puts it back, and then picks another card at random. Our key words here are the fact that she puts the card back. This means we had a 1 out of 52 chance of getting that whatever card she selected at first, and a 1 out of 52 chance of getting a specific card the second time. Since the probability didn't change, we can say that these are independent events. The probability of graduating high school in the U.S. is 88%. The probability of graduating college in 6 years in the U.S. is 56%. This is one where we can just use our common sense a little bit. For the most part, people graduate high school or get a GED before they graduate college. So we would say, just by using common sense, that these two are dependent. When flipping a coin, Jacob starts realizing that he starts to keep track of his heads and tails. He notices he's gotten 5 tails in a row. He feels like it will be very lucky if the next flip is tails. Is his 6th flip independent or dependent on the flips that came before? Well, if we think about the probability of flipping and landing on heads or tails, the probability of that is 1 out of 2 for either one. These are actually independent events, because every time I pick up the coin, I still have a 50% chance of getting one or the other. So, independent. On a math test, 5 out of 20 students got an A. If 3 students are chosen at random without replacement, what is the probability that all 3 got an A on the test? Here's some keywords to look at. Without replacement. That means for the first student that we pick, we had a 5 out of 20 chance that they had an A. For the second student, we were only drawing from 19 students. So the favorable outcomes changed, which makes these dependent events. So some of these we've already kind of talked about. If there's words that indicate that there was replacement, that's usually independent. Without replacement would usually be dependent. Now also, look to see if the favorable outcomes change between events. That would make them dependent. Don't forget to summarize what you've learned today, particularly about how to find the probability of the intersection and how to tell if 2 events are independent.